Okay, more notes on section 7.3, and as you can see, this is the 9th page of notes. So I hope you have enough examples. This is example 8, but we had some other sub-examples, so we've had plenty. Now we're going to do this with respect to y, and the solid lies between planes perpendicular to the y-axis at y equals -4 and 0. So these are planes perpendicular to the y-axis at -4 and 0. The cross sections perpendicular to the y-axis between these planes are semicircles. So we haven't done semicircles either. So this is a new kind of cross section, and now with respect to y. So another little variation, a couple variations. Okay, semicircles whose diagonals run from x equals 0, this is x equals 0, to the line x equals y plus 4. Now if you graph this, this is the same thing as y equals x minus 4, and you can see this is your x, so this is your intercept is -4, and your slope is 1. So you could draw the line. And these are the semicircles, and they're going to start from here, and they're just going to go right up for there. Semicircle, semicircle. So I kind of highlighted a couple of those for you. So again, the volume, now this is going to be with respect to y equals the area dy. The area with respect to y dy. Okay? So everything has got to be in terms of y, and it already is. We're in good shape here. So the area of a semicircle is 1/2 pi r squared. That's half of a circle. Now what's my area going to be? Well, my diagonal will be actually just this distance from here to here, which is basically given by this formula, y plus 4. And you can check that out. When y is 0, what's my diagonal? 4, because it's right there. Okay? That's when y is 0. And when y is -4, what's my diagonal? -4 plus 4 is 0. So that works out. Okay? But the radius is half the diameter, and I'm going to need the radius for the area of a circle, or semicircle, because it's 1/2 pi r squared. So that's going to be y plus 4 divided by 2. That's going to be my radius. So the area of a semicircle, of the area of the semicircle, is going to be 1/2 pi, and then times radius squared. 1/2 pi r squared. This is my radius. So I square that. I get y plus 4 squared all over 2 squared, which is 4. I did that so I can multiply this out and get pi over 8 times this. So there's my area. I'm integrating from -4 to 0 because it's with respect to y. So it's going from here to here. So this is what we've got. -4 to 0 of pi over 8 times this. So all this came from down here. Okay. I can take the pi over 8 out. I can square this. This would be y squared plus 8y plus 16. And then I can just take the antiderivative, y cubed over 3, 8y squared over 2, 16y, and evaluate that from -4 to 0. And pi over 8 in front. Now again, this is kind of a nice situation because, again, when I put 0 in here, I've got factors of 0 in each term, so that's going to be 0. That's going to be your f of b minus f of a. This is f of b minus, and this is the f of a. Again, we're applying that really fine application of the fundamental theorem of calculus. Okay. All right. Sometimes known as the integral evaluation technique or method. All right, so this is 0. And then if I put -4 in here, I get -4 cubed over 3, -4 squared. And then 2 goes into 8 4 times, so 4 times that, and then 16 times -4. So that ended up being a negative times, and a -4 is a -64, so that's positive 64 over 3. That's 16. Positive 16 times 4 is 64. And -4 times 16 is -64. These 64s become 0. So I got pi over 8 times 64 over 3. 8 goes into 64 8 times, so I got 8 pi over 3. There's your answer. Okay? And that's that. So I hope that helps. And good luck with the homework.